All right, so in section 2.5, we're just going to talk about some measures of position. These are just additional ways to talk about the placement of data. And we're going to start with the quartiles. The quartiles will divide the data set up into 4 roughly equal parts. All right, now if we're talking about splitting a data set up into 4 sections, then that means these equal parts will each hold about 25% of the data. Now, typically the way the quartiles are defined or interpreted is in terms of what comes on or below. And on or below is just another way of stating less than or equal to that value. So if we know that each section here holds 25% of the data, then the way we interpret these values is that when we find the first quartile, 25% of the data will be less than or equal to the first quartile. 50% of the data will be less than or equal to the second quartile, and then 75% of the data will be less than or equal to the third quartile. Now we're going to talk about how to actually find these values in just a minute, but we're going to be using these values to construct what we call a box and whisker plot. So I wanted to go ahead and show you an example of what that looks like. A box and whisker plot is going to graph what we call the 5-number summary. Okay, and the 5-number summary for a data set includes the minimum and the maximum values, and then it includes the 3 quartiles as well. So these other points that you see plotted here would represent Q1, Q2, and Q3. And remember how these values would be interpreted. So about 25% of these values would be less than or equal to 9, because that's Q1. About 50% of these values would be less than or equal to 16, because that's Q2. And about 75% of these data values would be less than or equal to 33, because that is Q3. And then remember, anytime we're graphing, we always want to make sure that we graph to scale. And so you'll notice this is set up relative to a number line where a scale is defined that spans from at least the minimum to the maximum value. All right, so let's start by looking at these two things together. We've got to find the quartiles before we can construct the graph. So we're going to go ahead and take this data set, which includes 20 values. These are number of vacation days. And what we're asked to do here is to find the quartiles of the data set. Now, there are always 3 quartiles because that's what it takes to divide a data set up into 4 parts. So that means we are looking for Q1, Q2, and Q3. Now we're going to start by finding Q2 first because you actually already know how to find the second quartile because it marks the 50% point in our data set. Q2 is the exact same thing as the median of the data. So notice what I did here. You have to be looking at ordered data to find the quartiles. So I went ahead and wrote these values in ascending order. And to find the median, remember our method here is to look for the central data value. Now, this is an even number of values. So remember, in that case, you actually have to focus in on the 2 central values to get balance, right? So now we have the same number of values on this side as we do on this side. Now remember, in the case where you have 2 central values, to find the median, you simply take their mean, which means our second quartile occurs at 4.5 days. Okay, and remember the interpretation. This means about 50% of the data values will be less than or equal to 4.5 days. All right, now, what the second quartile is going to do is it's going to split the data set right down the middle. All right, now when you split the data set right down the middle, you're going to look at the first half of values as those below the median. You're going to look at the second half of the values as those above the median. And all you're going to do to separate these halves into quarters is take another median, but look at this specifically for the first half of the data. All right, so my first half of the data contains 10 values. Again, we're talking about an even number of values. So we're going to look for the two middle values, right? 4 on one side, 4 on the other. And to get the median, right, we know we take their mean, but since these are the same values, right, it's not really necessary. We're going to have a first quartile at 2 days. And our interpretation here, again, about 25% of the data values will be less than or equal to 2 days. All right, so you can probably guess here what we're going to be doing to find the third quartile. And in that case, to get our upper half of the data, again, we're going to look at those values that fall above that median. Still 10 values that we're talking about there. And we're going to find the third quartile by taking another median, but for the second half of our data. All right, so once again, I'm going to look for the two central values, same number on one side as we have on the other, and to get their median, I will add those values together and divide by 2. And I'm looking at a third quartile of 6.5 days. So about 75% of the data will be less than or equal to 6.5. All right, now, once I do that, once I find those quartiles, which, by the way, can also be found using the calculator or StatCrunch, then I'm able to construct the box and whisker plot because I'm able to get the full 5-number summary. Okay, so from here, when I'm asked to construct the box and whisker plot, the first thing that I'm going to do is I'm going to write down my 5-number summary. Okay, now that includes the minimum. It includes the 3 quartiles. So we just found Q1 was at 2. Q2 was at 4.5. Q3 was at 6.5. And our maximum value is 10. Okay, that's all I need to construct the box and whisker plot. So notice what I did. I came down here to my number line. I defined a scale. I went by 2s, making sure that I at least went from 0 to 10. And then what I'm going to do is I'm going to plot the 5-number summary above that number line. Okay, so I'm going to put a point here at 0. I'm going to put a point at 2 because that's Q1. I'm going to put a point at approximately 4.5. That's Q2. And then 6.5 is Q3. And then my maximum is out here at 10. Now, all I have to do to construct my box and whisker plot is draw a box that runs from Q1 to Q3. All right, that will always run from Q1 to Q3. At Q2, to mark the median, just going to draw a vertical line. And then we will have whiskers that extend out to the minimum value as well as the maximum value. So in the homework for section 2.5, you're going to be looking at different data sets, finding the quartiles, writing the 5-number summary, and then constructing this box and whisker plot. All right, and it's always going to be done the same way. You're also going to be asked to read box and whisker plots when they're given to you. So, if you're given a box and whisker plot, being able to determine the range, being able to determine the median, that central value, all those are things that you can use the box and whisker plot to find. All right, so the last thing you're going to be looking at in section 2.5 is how you can use the interquartile range to identify outliers or extreme values. So in section 2.4, you looked at using the empirical rule to figure out where extreme values fell, but that would only work for bell-shaped data. So this is going to give us an alternative method that we can use for data, whether it is bell-shaped or not. All right, so I've given you the 5 basic steps that you're going to use to do this, but it is going to revolve around that interquartile range. Okay, so the first thing I'm going to do anytime I'm using the quartiles is I'm going to go ahead and make sure that I have the complete 5-number summary for my data set. Okay, and so because we've already found this, I'm just going to refer back. We had a minimum of 0, a maximum of 10, and quartiles of 2, 4.5, and 6.5. All right, so again, I'm just going to pull those because this is what we're going to need. All right, and then what I'm going to do is go ahead and calculate my interquartile range, because again, what we're doing here is using the interquartile range to determine if there are any outliers or extreme values. So our interquartile range is just going to take the third quartile, which is 6.5, and subtract the first quartile, which is 2. And that's going to give me an interquartile range of 4.5. All right, now, if you look back up here at your steps, you'll notice step number 3 says we're going to multiply by 1.5, and that 1.5 is a constant, so it'll always be 1.5 that you're using here. So I'm going to take that interquartile range, and I'm going to multiply that interquartile range by 1.5. So our interquartile range was 4.5. If I multiply that by 1.5, then I'm going to be looking at a span of 6.75. And then what I'm going to do is I'm going to take that span and I'm going to look to see if I have any values that fall further than that away from the box in my box and whisker plot. So the first thing I'm going to do is I'm going to look on the low side. All right, so I'm going to take Q1 and subtract this 1.5 times the interquartile range. So Q1 is 2. I'm going to subtract what I just calculated at 6.75. And notice that's actually going to give me a negative number, and that's okay. Now what I'm looking to see as far as any outliers is if I have anything less than that value. All right, now if you look back up at our 5-number summary, our minimum value was 0. So there's not going to be anything in our data set that is less than negative 4.75. All right, what that tells me is on the low end, I don't have any outliers to worry about. Okay, but outliers can be on the low end, they can also be on the high end. So the last thing I'm going to do is check the high end and see if I have any values that are past that. So I'm going to take Q3, the upper end of the box, and I'm going to add 1.5 times the interquartile range. All right, so Q3 is at 6.5. Again, I'm going to add that value. 1.5 times the interquartile range was 6.75. And that's going to put me with a span. That's going to put me at a value, essentially a value on a number line, at 13.75. 13.25. Okay, and again, what I'm looking for here would be anything greater than that value. So if I look back at my 5-number summary, my maximum data value is at 10. So that tells me I'm going to have no values that are more than this upper limit of 13.25. And what that tells me is there are no outliers on the high end of my data. So at this point, I've checked the low end, I've checked the high end. I don't have any values that fall outside of this range. And so I can now say there are no outliers, no extreme values in this data set. Now something else you can do with this is you can look at these values in terms of your box and whisker plot. All right, and I've kind of drawn you a little sketch of that here. These numbers that we calculated are often called fences because, again, what you're looking to see if anything goes past those fences. So if you look at your number line and you kind of approximate where that lower value is and where that upper value is on your number line, and draw yourself a little fence, anything that stays within those fences, all right, so anything that's in here is not considered an outlier. But if you had any part of your box and whisker plot, any data values that were outside of that went past those fences, that is where you would report an outlier or an extreme value. Okay, so just so you can compare, I'm going to go back and look at the first example so you can see what it would look like if I did have an extreme value. And you'll notice here I've actually already gone through and calculated those fences. So notice I did my inner quartile range, which is where I start. All right, right there. Q3 minus Q1 has a span of 24. I took 1.5 times the inner quartile range. There's that constant number, and that gave me a value of 36. Okay, and then notice what I did with that. I looked at subtracting Q1 minus that value of 36, and I said again that's going to put me down here in negative numbers, and I'm not going to have anything that goes past that fence because the lowest value here was at 6. But on the high side, when I took Q3 and I added that value of 36, it put me right here with a fence at 69. So anything past that would be considered an outlier. And so that's why when I saw this number right up here, my maximum at 104, I know that's going to be an outlier, an extreme value, because it goes past the upper fence. All right, now I want to go ahead and caution you, section 2.5 also looks at percentiles and it looks at z-scores. We are going to wait and talk about these things in chapter 5 when we actually need to use them. So all your homework's going to focus on and all you need to worry about as far as this upcoming test from section 2.5 is going to be finding the quartiles, the 5-number summary, constructing a box and whisker plot, reading one, answering questions from one, and then this last thing here, which is using the inner quartile range to identify outliers.